Hello, calculus student. This is for chapter 3.6, part 3. Still chain rule, but a more difficult part of chain rule. So in part 1 and 2, we work on examples where we use general power rule or chain rule to find derivative of a function. Now, this would be mixing chain rule with product rule and quotient rule. So sometimes what we have is we need to use chain rule during one of the f or g derivative, or actually the inside of a derivative of a general power is a chain rule, is a product rule or a quotient rule. So an example would be like this. Find a derivative of y equal to x plus 1 over x minus 3 cube. So you can see that the outside is a cube, the inside is a function that involves quotient. So this is inside, but the inside is a quotient. So this is inside g of x, so we can use general power rule. So you would say dy dx would equal to just do this would be like g of x to the cube. So I would do 3 of the whole g of x plus 1 over x minus 1, but square. So this is kind of the general power rule. And then do a dx of just this quotient. Now this would be a quotient rule, so we'll do f. So I still do g, but this g is now this one, right? F is x plus 1, g is x minus 1, f prime is 1, g prime is also 1, because when you take derivative of this. So the final answer would be x plus 1, x minus 1 square times g square. G square is x minus 1 square. Fig minus g. Fig is 1 times x minus 1 minus gif, 1 times x plus 1. And if you combine like term, so this particular part would keep this particular x minus 1, x plus 1, x minus 1 square. And this would be the x and x cancel, negative 2x. No, negative 2 over x minus 1 square. And then you can multiply the negative 2 with the 3. It will be negative 6 x plus 1 square over x minus 1 to the 4th time. That's the final answer. Let me write here. Negative x plus 1 square over x minus 1 4 times, because it was 2 times here and 2 times here. So that's the final answer. Second example, I have x squared and a square root of x minus 1. So this looks like a product rule. X squared is f is equal to x squared. G is square root of x minus 1, right? But square root of x minus 1, I would need to use chain rule. Okay, so f prime is just simple 2x, but g prime would involve a inside of x minus 1 and outside of x minus 1 to the 1/2. Anytime the inside of a square root is not x, you have chain rule. So that would equal to 1/2 x minus 1 to the power negative 1/2 times d dx of x minus 1. But fortunately, d dx of x minus 1 is just 1, right? So that is 1/2 x minus 1 to the negative 1/2 times 1. Okay, so we have f and g done now. So dy dx, we're going to fig plus g, 2x times the g, x minus 1 plus gif, 1/2 square root of x plus 1, because negative 1/2 means this, right? Times x squared. So now this doesn't have a denominator. This has a denominator. Common denominator, it become 2x, x minus 1 over, well, actually it should be 4, right? So I would multiply 2 square root of, so 2 of x minus 1 plus x squared over 2 of x minus 1. Common denominator, 4x squared plus x squared equal to 5x squared minus 4x over 2 square root of x minus 1. Okay. We like to combine it. Sometimes some computer system accept this as the answer, but if you want a common denominator, this is the one that you will get. Example 3, find the derivative of square root of 1 sine square 2x. There's so many chain rule involved. The outside, the main outside is a square root. Main inside is 1 plus sine square 6x. So we write it as y equal to 1 plus sine square 6x. This is really a hard, difficult one. So use chain rule because this is inside, this is outside. So dy dx would be equal to 1/2 of 1 plus sine square 6x to the negative 1/2, and then do a d dx of 1 plus sine square 6x, right? But this, in this particular one, that involve two chain rules, sine 6x square, right? So I would do 1 over 2 square root of 1 plus sine square 6x, because it's a negative 1/2, times over this, derivative of 1 is nothing, it's 0. Derivative of this would be, so I can write it as sine 6x, that's the inside, the outside is a square. So do a derivative of this would be times 2 sine 6x to the 1 power. And then do a derivative of what? What's the derivative? Derivative also has the inside and the outside. Cosine 6x. And then the inside times 6. So this would be the final answer. And 2 and 2 cancel. So that would equal to, the top would be 6 sine 6x cosine 6x square root of 1 plus sine square 6x. Okay. So example 4. Do I have one more example to do? Yeah, maybe I'll do this example and then we'll do the 5 in class. It's very long. So find the derivative of cosine x over x minus 4. Of course, the outside is a cosine, the inside is x over x minus 4, right? So dy dx would be, if you have cosine of something, the derivative is negative sine of the same thing. The sine of x over x minus 4 times derivative of x over x minus 4. But this is a quotient, so I would keep on having negative sine x over x minus 4 as the outside. And then this would be fixed and shift. G fixed is x, g is x minus 4, right? F prime equal to 1, g prime equal to 1. And then, so what would it be? It would be x minus 4 square, g square, big 1 times x minus 4. 1 times x minus 4 minus GIF 1 times x. X and x cancel, so ultimately it's negative sine x over x minus 4 times negative 4 over x minus 4 square. So you are doing a chain rule for the cosine of this, but when you do the derivative of this, it's a quotient rule. And then This one maybe we'll do it in class. Square root of a sine over a 1 plus cosine x. So this is a quotient rule again. The last one we want to do is if I have this is a very common question. I have a function that is y equal to sine square pi x. I want to do the equation of a tangent line. Okay, so at 1/4 and 1/2, that means x equal to 1/4, y is 1/2. Okay, so let's do the slope of the tangent line. F prime of x, right, or y prime equal to the slope of the tangent line. Okay, so what is the slope of the tangent line for this? So we would just do dy dx of sine square pi x. So this is sine square pi x. What's the most outside function? So you can think of sine square pi x as sine pi x, right? And then square. So the outside function is the square. So do general power rule, 2 sine pi x. The inside to the power 1, right? And then I do d dx of sine pi x. Now when I do d dx of sine pi x, the outside is sine now. So that would equal to 2 sine pi x to the power 1 means just sine pi x times cosine pi x, right? And then times d dx, the inside is pi x, which is pi. So this become pi. The pen is not very good. So become 2 pi. These are all constant. Sine pi x cosine pi x. I plug in 1/4 to it, so it'll be f prime of 1/4. The slope would be 2 pi sine pi over 4 cosine pi over 4. Sine over 4 and cosine pi over 4 are root 2 over 2. So you multiply them, it's 1/2. So 2 pi equal to 2 pi times 1/2 equal to pi. So ultimately, the slope is pi. So what is the equation? The equation is y minus 1/2 equal to m pi x minus 1/4. Right? So you do that would be y equal to pi x minus pi over 4 plus 1/2. Oh. We need more space there. Plus 1/2. That is the equation of the tangent line. Very not enough space. Right? Because we find this we find this is the slope, okay, when we plug in 1/4 1 pi, so then this is point slope form. So that's end of the chain rule, chapter 3.6.